This is my quadcopter, and I'm doing this video to show how I put it all together and what parts I used, and I will also be showing some test flights of the quadcopter in action. The main part that I needed was the Ardu flyer, or the Ardu pilot. I bought an Ardu flyer from RC Timer. It comes it does not come assembled. You have to solder all the points on it yourself. You could get the same thing from 3D Robotics, pre-assembled, and it comes with the case. RC Timer cost $80, whereas 3D Robotics cost $200. So I went with the cheaper route, and I ended up buying the case separately. The case was about $5, so $85 compared to $200. So I saved quite a bit of money on that. The next main part that you need is the frame, and the frame that I got was just one of their basic DJI frames. It comes with the board right here, and this one here as well. This one on the bottom is a power distribution board, so all the power gets just distributed among all the components. So the ESCs, the motors, the Ardu pilot, the GPS, the telemetry kit. Everything on there gets the power just from that board. Once you've got your frame, you can sort of estimate how much your quadcopter is going to weigh. Mine, I can show you right here. Weighs 1,203 grams, and which is roughly 2.6 pounds. So it's not a light quadcopter, that's for sure. But and once you know how much your quadcopter is going to weigh, you can figure out what type of motors you're going to need. The motors I chose were these ones right here. It is a 2212-1000 kV Outrunner brushless motor. And I had to get 4 of them because I have a quadcopter. And at maximum throttle, they get about 750 grams of thrust. And with 4 of them, that's 3,000 grams of thrust, which will easily lift my quadcopter, even if I added a lot of other components, such as a camera or whatever else I wanted. Okay. And once you have those, you need to decide on your ESC, or your electric speed controller. Again, I chose the ESC 30 amp from RC Timer. Okay, and then if you were to go with this one, you'd have to get a programming card right here. This card allows you to program all the settings on the ESCs. Mine is right here. And if this will focus, let me see it again. Anyways, these allow you basically to set the program the settings for like the brake, the different type of battery, whatever it is, like LiPo or nickel. It allows you to set the cutoff voltage, the timing, and any of those other kind of things. So, and then after that, you need to choose your telemetry kit, which I went with the 915 megahertz radio telemetry kit. It comes with the one that goes on the quadcopter and the one that goes into the computer. This is really important for if you're wanting to use your quadcopter in autonomous mode, meaning it flies on its own. And here is mine. Notice that on the web page it does not have a case on it. They just come bare with all the components exposed. So I ended up making my own case using a 3D printer. I downloaded the template from a website called Thingiverse, and it was just pre-designed for me, so I just plugged that into a 3D printer, and this one came out. There's an opening in there, so that way you can see the lights in it. It'll have a green light saying that's connected to the other component, and there will be a flashing red light indicating that it is transmitting or receiving data from the other or to the other. Alright, after that you need to choose your GPS. I went with a U-Blocks GPS, and I'll show you that on here. This is my U-Blocks GPS that I chose. Okay, and then after that you need to get your transmitter and your receiver. This is going to be used for either flying in auto mode. There's a safety feature in there which I'll go over later that requires you to have a transmitter, and it's also obviously used for manual mode. My quadcopter is mainly going to be in auto mode, but first calibrating everything, I'll be needing it to try it out in manual. Alright, next thing you need to do is get the proper battery. Make sure you have one that's strong enough to power all 4 motors, not just one. Make sure it's pretty large. This one is a 5000 milliamp 25C battery. As you can see, they're a little pricey. This one is $62.64 on Amazon, and that's with a Prime discount. Otherwise, they're about $130. So they're pricey, but you need it. Also, to go along with that, make sure you have the proper connector to connect your battery to your board. Don't jimmy rig this, because this, if this connection comes undone while it's in mid-flight, your quadcopter is going to come crashing down. Alright. Also, as a safety mechanism, I ended up putting in a toggle switch right here. This is just connecting my battery to my board. The reason why I put this in here was because whenever you plug the battery in, the blades like to twitch a little bit whenever it's doing its chirping sequence. If you aren't careful, and like you have your throttle up or something like that, something goes wrong, the blades can start spinning while you're plugging it in, and these blades are really sharp, so it's really dangerous. So what I ended up doing was I put in this toggle switch. That way you can just flip the switch really quickly and have your hand out really quick. It's a lot safer, and also the blades don't reach the switch, so you can be out of harm's way really quickly. Alright, and speaking of the propellers, that's the next thing you need to determine what you want. I ended up going with a 9x5" propeller. These ones are carbon fiber. The reason why I went with these ones is because they're very strong and durable. I knew that with my first few flights I'll probably be crashing quite a bit, so I wanted something that would withstand all that kind of damage. So I went with these. But since they're so durable, they can be very dangerous as well. If your hand gets in there, since they're so strong, the blades won't break. They're going to cut you instead. So just make sure you have your hands well out of the way, and whenever you're not actually flying, make sure the blades are off. I only have them on in this video just to show the full product, and also to be able to get the full weight on that scale. So now to show how everything is set up, we have down here our power distribution board, and right here there are these little solder points. You just take your ESCs and solder them straight to the board, black being negative, red being positive, and there is one on each corner. Okay, and then also on this side there are 2 more parts. There's one right here and here. This is where the battery connects. Again, they're just solder points, and you just solder those on. I then have right from there going up to the switch, and then from the switch goes to the battery. And so all the power from the distribution board will be going out to the 4 ESCs, and then the ESCs transfer the power out to the motors. And I can show you that. Okay. When connecting the ESCs to the motors, it does not matter which thing you connect to where. The only thing that does matter is which way the motors will spin. Right here is the front of my board, or my quadcopter, and this is going to be motor 1, motor 2, motor 3, and motor 4. Motors 1 and 2 both spin counterclockwise. 3 and 4 spin clockwise. The reason why they spin opposite directions is so that way everything balances properly, and if they all spun the same direction whenever it was lifting off, the quadcopter would just be spinning in circles. So it's not very stable that way. So if you have them alternating, then it flies really well. And if your motors are spinning the opposite ways that you want, all you have to do is take 2 out of the 3 cables and disconnect them and swap them. So if you had these 3 connected to these 3 in that order, but you wanted it to spin the opposite way, you could just take the black and the blue and swap them, or the black and the red and swap them, or the blue and the red and swap them. Just choose one, and then you should be good. Again, it does not matter which one you choose. Alright? And then plugging everything into the ArduPilot, we'll start with the outputs. ESC1 will plug into output 1, ESC2 will plug into output 2, ESC3 will plug into output 3, and ESC4 will plug into output 4. Then on the inputs, you want to be connecting your receiver for your transmitter into the inputs. And again, they just plug straight into 1, 2, 3, and 4, where 1 is the roll and aileron, input 2 is your pitch and elevator, input 3 is your throttle, and input 4 is your yaw and rudder. Okay? And then, to get power to your board, to your ArduPilot, you have 2 options. You can use a power modulator right here, and I did not choose to go that way just because it adds extra wires, extra connections, and all that kind of stuff, and it therefore adds a little extra weight. The other option is to power it through the outputs. In order to do this, though, you have to have this jumper right here where it says JP1. There's just like this really small jumper right there in that hole, and that allows the power from the ESCs to get into your ArduPilot. After that, you just have to connect your telemetry kit into this little spot right here where it says telemetry, and you connect your GPS into the spot where it says GPS. Those are all the connections you need to make. Make sure everything is securely fastened to the board. For example, I have my receiver secured down, I have my GPS secured down, I've got all these wires strapped down as much as I can, the antennas are all taped down so that way nothing gets up into the blades. It is very important that nothing gets in the way, because if it does, it'll get damaged. If your quadcopter comes falling, that's even more damage. So just make sure you have everything securely fastened, and that is how you assemble everything. Next, I will go over how to program everything. In order to program your ArduPilot, you need a program called Mission Planner. This is a free program you can download online, and it is all open source, so any troubleshooting, you just go to the forums and that kind of thing. This program allows you to do a lot of different things. There is a bunch of different gauges that will tell you your speed, your altitude, your direction, that kind of thing. There's also these different actions you can do. You can do like a pre-flight calibration, you can do a loiter, you can return to launch, and if you push this button right here that says do action, that's how you do whatever is selected right there. You can set it to auto mode, manual mode, and you can arm and disarm your quadcopter. You can even use a USB joystick instead of a transmitter if you wanted to. There's a bunch of different hardwares that you can use. Right here is the quadcopter design that we would be using. Whenever you select this one, it'll give you a choice of the plus design or an X design. Plus being to where the front is one of the blades, the X is to where the front is in between the blades. Whereas in mine, this is my front right there, it is in between the blades, so we would choose the X design instead of the plus. There's also a bunch of different software that you can do, and you can simulate stuff, you can write your own code, that kind of thing. And then in order to connect your quadcopter to the computer, you need to take your telemetry kit and plug it into the USB. You need to choose the correct port that it's coming from. Mine, for example, is COM7, and then you need to choose the correct speed, which mine is 57,600. After that, you'll just hit connect, but first you need to turn your quadcopter on. And for safety reasons, I am going to take my propellers off. As you can see, I have the propellers now off. I did that for safety reasons. I do not want the quadcopter taking off whenever I'm programming everything. So again, whenever you're not ready to fly, make sure your propellers are off. In order to turn this on, I just have to flip the switch, and you'll hear a series of beeps. The lights on the autopilot will light up, and the motors will twist just a little bit. And here we go. Okay, again, there's this light flashing up here. Sometimes it's red, sometimes it's blue, sometimes it alternates. Whenever it's flashing like that, that means everything is good. And then you want to turn your transmitter on. When you do that, an orange light down here on the receiver should turn on. This indicates that the receiver and the transmitter are connecting together. Again, this telemetry kit will have a solid green light indicating that it is connecting to this one right here. That does not mean it is connected to the computer though, it's just connected to each of the receivers. Okay? Right, now back to the mission planner. All you have to do after choosing the correct port and speed, you just hit the connect button. When you do that, this screen will come up. This is just saying it's getting all the parameters and stuff and reading what is currently on the autopilot. It takes a moment. It's got a lot of information to gather. Right, and now that it's connected, we have a lot more options in the software and the hardware. One of the things you can do is set your flight modes. You can choose like stabilize or hold altitude or auto mode, that kind of thing. You also have your PIDs. You can fine-tune your PIDs in this window. A lot of times the autopilot will self-calibrate everything, but you can change the rate at which everything stabilizes. In the hardware, you will be able to do some other stuff, such as your controller. It's under mandatory hardware and radio calibration. All you have to do is hit calibrate radio and then move all of your sticks up and down to their max and left and right to their max. This will show the max and the min of what each stick can do. Okay, and then back here to Flight Planner, you can in this you can add different like waypoints and stuff like that. In order to do this, there's a couple different ways you can do it. You hit this add below, and you can say, for example, takeoff, and then you add below, and you can say loiter, and then if you add another one, let's have it land. Right, and you can control the altitude, like right here, let's say it's going to go 10 feet. Let's say right here it's going to loiter for 100 seconds, and then it's just going to return to the land. Okay. Then once you're done with that, you can either come over here and hit write waypoints. That would write all this data that you just created to this autopilot. Also, if you want to get whatever is already on it, you can hit read waypoints. Currently I have this mission already planned on there, so that it will just bring up that same thing. Another thing you can do is you can add waypoints. So you can either click here and say waypoint and then you put in the coordinates, or you can just come here and click on the map and just put whatever waypoints you want. Alright, that's pretty simple. So I'm just going to go ahead and delete all these and read the waypoints from my autopilot. Right, and that's the mission that is currently on it. Once a mission is stored on the autopilot, it is free to go. You don't have to be connected in any way other than to arm the motors, and then it'll fly off on its own. It can fly well past the range of the telemetry kit, and as long as it still has battery, it'll finish whatever it's doing. It knows where it's at based on the GPS that is located on the quadcopter itself, not based on what the computer says. Alright, and then for the flight data screen, we'll go back to actions, and this window right here shows all the information that it's being gathered from the autopilot. And if I were to pick this quadcopter up and just start tilting it, you can see that it's just going crazy right now. So it's registering all the tilt and the yaw and the pitch and all that kind of stuff. There's even a compass right here. The red line indicates the front of the quadcopter. Right now I'm turning it, and so there's that. There's even a compass up here at the top. Okay. Alright, and other than that, in order to get everything ready for flight, you can do this pre-calibration. That just levels everything out, gets everything set up, and then you can choose auto or manual mode to start off with. I'll choose manual just to show that everything is working. And then you have to arm the motors. If you don't do this, then it's not going to work even if you push the throttle up. Right, it is now armed, as you can see, and as soon as I move the throttle up, the motor starts spinning. You can also set it to auto mode. Once you do that, you would think that it would just start taking off, right? Well, there's a safety feature in there, like I said earlier. You first have to move the throttle up, and then it doesn't matter what you do with the throttle, it's just going to go into its own mission. I'm going to go ahead and disarm them, so that way I don't drain all my battery. The reason for the safety feature is so that way if you were in here working on Mission Planner and you hit auto mode, it's not going to take off whenever it's sitting right next to you and cut off your arm. So, in order to prevent that, they make it to where you have to use the transmitter to set the throttle up. This prevents any accidents just via the computer. So, again, you need a transmitter in order to be able to fly in autonomous mode, even though you don't want to control it with the transmitter. It's just to work around the safety feature. Also, the transmitter is used for calibrating the ESCs to maximum throttle like I showed earlier. Other than that, there is nothing else that needs to be done other than working out the kinks. Make sure your quadcopter is balanced properly, and that's about it.